All right, recording is rolling. Welcome to Wednesday, November 1st. So we're going to preview a lab for tomorrow. I've talked a bit about this leading up last few days, but tomorrow will be the pulleys lab. So we'll look at that. I have gone over all the physics puzzles with you guys, right? We did all those yesterday, but I want to give you guys time and class to work on those independently. So you guys can remember all the ones that I circled is ones that I'm picking up that's going to be due Friday, right? I have gone over this in class, like how to solve them, right? If you finish all those, then of course you're always welcome to look at the questions that I didn't circle, right? Like the more time you spend with the subject, the better you're gonna get at it. So there's always extra opportunities in the class, right? All right, then okay, so yeah, puzzles due Friday. I want to give you guys an opportunity to like full focus on those puzzles today and be able to work independently on those. I have printed out your guys' next quiz, so I'll get that to you guys by the end of class today. Let's have that due on Monday. So you guys have a few days to do that. Of course, we got this fun resiliency schedule with 40-minute classes. So here's what the schedule is going to be looking like. You guys have probably checked focus to see where you're going to be. Well, it looks like next class is we're in second period right here, right? All right. So please switch my screen over and let's look at this pulleys lab. Pulleys. Oh, yeah. Yeah. All right, so that'd be like a 3-1 mechanical advantage right there, right? Right. That's the one I got a poster for. So switch screen back over here. I fill you guys in on these details. So near the beginning of that video, they mentioned a few different types of supplement machines. Here's a fuller list, right? Different ways you can get a mechanical advantage, right? And tomorrow, your lab, we're going to focus on this one in particular, right? This pulley system. I'll have you guys bring up different type pulley systems. Okay, here's the 3 to 1. I'm going to focus on this one. Just go through my example, right? They talked about like fixed pulleys versus a movable pulley. Could you guys imagine this being like an animation? These two would be fixed in place. And this one could like move up and down. I have one rigged up in class here, which is like a 5-1 mechanical advantage. Right, you guys can see that in operation. Right? See that in motion. Okay. Ooh, do you guys see a small weight that's like lifting a large weight? Ooh, right, something like that. Right. So how's this working? Well, the guiding principle is this right here. It's actually like a conservation of energy type approach, right? Which says that you can get a mechanical advantage. You can amplify your strength, but you can't actually amplify the amount of energy, right? You can't amplify the number of joules. The number of joules is always constant, right? It'd be nice if you could violate that. You could run the entire world's electricity grid on one lump of coal forever, but energy doesn't work that way, right? You have to keep mining coal, blah, blah, right? So the amount of work output you can get, like lifting this thing, can only ever be as much as the work input. And if it's 100% efficient, then you can just equate this to. So this is showing like 100% efficiency, something like that, right? Okay. So force times distance in equals force times distance out. What that means then is that you can, with just a small input force, lift something that's very heavy. Right here, maybe like 3 to 1. Now, how do I know it's 3 to 1? But well, a good rule of thumb is if you look at the movable pulley, if you count the number of strings going upward, it's kind of like this weight has been divvied by that number of strings. Right? Like here, let's attach some numbers. What if this weighs 300 newtons? 300 newtons this weighs, right? What's the tension in each string? Split 3 ways. That'll be 100 newtons, right? 300 divided by 3, right? Oh, so the tension in the string is only 100 newtons. Route that over to the spring scale. Now the spring scale is only reading 100 newtons, right? So now 100 newtons can actually lift 300 newtons. Right? Now the catch is, of course, you have to pull lots and lots and lots of strings to make that happen, right? So if you pull just with 100 newtons, you pull, say, like 30 centimeters, it might take 300 newtons, lift like 10 centimeters, right? Okay, so a heavy weight, you're lifting just a little bit at a time, right? Okay, so force times distance equals force times distance, right? So here, do it again. So 100 newtons times 30 centimeters would be equivalent to 300 newtons, only moving up 10 centimeters, right? So equal number of joules, right? Now it's assuming 100% efficiency. So what's the mechanical advantage? Well, there's actually 2 different perspectives on mechanical advantage. There's ideal versus actual. The ideal mechanical advantage is just based on the geometry. So here it's okay, 3 to 1, I'm calling this a 3 to 1 mechanical advantage. But really, that's just an ideal scenario. In reality, well, maybe you have a little bit of frictional loss, or maybe these strings aren't exactly vertical. If you bring in trigonometry, it's a little bit of velocity process. Right? So your actual mechanical advantage is the ratio of the forces, which might be a little bit less than 3 to 1. Right? Maybe it's like 2.7 to 1 or something like that, right? Something else you could get to this, I think this was a textbook question yesterday, was what's the efficiency of the system? I think yesterday I showed you guys 2 different ways to get efficiency. You can take the ratio of the actual versus ideal mechanical advantage, or you could do the ratio of output compared to input work. Right? It ends up being the same expression at the end. Again, maybe something like 0.90, like 90%, something like that, right? Then tomorrow I'll have you guys rig up lots of different type pulley systems. Oh, I'm looking at 1-to-1 mechanical advantage, which isn't really an advantage other than just redirecting the direction of the force. A 2-to-1, so now you're twice as strong. A 3-to-1, now you're 3 times as strong. And ooh, I've got like a 4-to-1 here, we're like 4 times as strong. Got these little pulleys. There's some, I don't have one right in front of me, but there's some of these pulleys that's like double pulleys. You guys have probably seen those in the past too, like double pulleys. You can actually have this as like a double pulley, just drop the string under a couple times, right? Independent wheels, like that. Okay. I'm gonna have you guys keep track of what's the weight you're lifting versus what's the input force, what's the distances each of these move, like how much do I pull versus how much does it lift, right? And then calculate what is your ideal versus your actual mechanical advantage. I might go back and modify this table and include an extra row for efficiency, would be a good thing to be able to calculate too. So this is gonna be tomorrow's adventure right there. Okay, so I'm gonna give you guys rest of the day to full focus on these puzzles. Any you haven't solved yet that's circled, good opportunity to do that. I can walk around and help you guys out. If you solved all the circled ones, then good opportunity to look at the ones that I didn't circle, right? It's always extra good solve, right? Or maybe set up to take a paper out, break it into quadrants, and start set up these tables for tomorrow's lab too, right? All right, so I'll give you guys rest of class to do all of that. Ask me any questions if you have any questions. Remember, we got this modified schedule today, so there's the schedule right there. Okay, and here, leave this up if you want to copy that down. All right, and that'll be a wrap on the video. Oh, wait, sorry, one more thing right before I hit. All right. I will get you guys this quiz at the end of class, right? So end of class, I'll give you guys a quiz, and the quiz is due on Monday, right? And